All right, yeah, this is kind of what I wanted to cover a little bit here. This is a really simple math problem. 3 times 2 plus 1 times 4. Obviously, multiplication has precedence over addition. Very simple. 6 plus 4 is 10. There shouldn't be any question about that. 3 times 2 is the same thing as adding 3 twice. 1 times 4 is the same as adding 1 4 times. You could convert that all to addition, and there you go. You'd be all set. All right. But I look at the comments here, and some people really just, I'm sorry about the bouncing there. Let's stop that. There's some really bad trolling going on here. Because before you people were born in primary school, if this question was asked verbally, everyone in the class would get it right. The teacher would say, "What's 3 times 2? Now add 1 and multiply by 4." The class would answer 28. Miss 28. Now try to convince me your system makes sense. What a load of rubbish. Crash course, I don't think so. You know nothing about math. All right, first of all, this is written out pretty clearly. This is not verbal. It's 3 times 2 plus 1 times 4. Fairly simple. What he doesn't understand is that what he's trying to do would require parentheses. You would have to have parentheses around 3 times 2 plus 1, and then multiply that by 4. Do you see parentheses? No, I don't. But, I mentioned, hey, I'm in my 60s. Please don't make excuses for not understanding. But then, I explained the math to him, but really, he still doesn't get it. And this happens quite often. Unfortunately, he said he asked some people. Just a few moments ago, I asked a couple of kids on their way to our pool this question. What's 4 plus 4? Both answered 8. Now double it and add 4. Again, he's trying to turn this into some kind of a verbal problem, which this is really not verbal whatsoever. Again, I've seen people do this before, and I don't know. I've seen people do this one before where they try to turn this into a verbal problem, and unfortunately, with some people, they just really refuse to understand the order of operations. So, and you also run into people who are really just kind of acting as trolls online. So, I've kind of learned to try to ignore that stuff as much as I can. But he's trying to say that this is my teachings. This is the order of operations. In Western civilization, this stuff goes back to like the 1500s. So uh, he thinks I'm teaching rubbish, but unfortunately, really, Peter McGarry, unfortunately, you really should stop commenting on this stuff. I sent him a link to a 1922 textbook. He's talking about classes in the 1940s. And I just showed him a 1922 textbook. This stuff is not new. This is old stuff, guys. So yeah, I have to do this stuff every once in a while because people really are missing out. This is a 1913 textbook, by the way. Try to zoom in here. The fundamental operations are addition, subtraction, multiplication, and division. Indicated operations are to be performed in the following order. First, all multiplications and divisions in their order from left to right, then all additions and subtractions from left to right. Pretty basic stuff. Pretty basic stuff. Let's take a look at another one. Guess what, guys? This one here is 1922. This is an excerpt from a 1922 textbook. He really needs to understand parentheses. A parenthesis expresses the fact that the quantities within the parentheses are to be taken as a group and to be treated as a single or individual quantity. 7 minus 2 plus 3 means that the sum of 2 and 3 is to be subtracted from 7, which gives a remainder of 2. The So yeah, back to looking at this again. It's pretty clear right here. They talk about this is a 1922 textbook, and they talk about how parentheses give you priority. When you have 7 minus 2 plus 3, but you have the 2 plus 3 in parentheses, it's telling you that you're subtracting 5 from 7. That's pretty clear. So this whole thing goes through, and it even tells you that multiplication and division signs take precedence of addition and subtraction signs. The first two signs unite the numbers between which they are placed. And you know what? That's a great explanation. It's one thing that people mess up all the time. The signs unite the numbers between which they're placed. Sometimes I see people do crazy things like take a negative sign and attribute it to numbers that are two or three positions away, and it's between two numbers. But again, you have something like 12 minus 10 divided by 2. It indicates that the 10 is to be divided by 2, and the quotient is to be subtracted from 12, which gives you 7 as the result. But, I show these three different textbooks. We've got this one from 1922. I've got a 1950s version. And also, I'll show you the 1930s version, or 1913 version. And here's the 1913 textbook. Now, of course, unfortunately, with Peter McGarry, the only thing that he looked at on here was the word algebra at the top. And as soon as he saw algebra, he started to call foul because he's like, well, we're not talking about algebra here. And again, I've gone through this before. The order of operations convention applies to algebraic and non-algebraic expressions and equations. It makes no difference that this is from an algebra book. The basic order of operations applies when you don't have any variables, when you're not dealing with any variables. But still, the same fundamental operations apply. Multiplication, addition, subtraction, and division don't change from algebra to something non-algebraic. They're always the same. They don't change definitions. Look them up. They're in the dictionary. It's very simple. You have fundamental operations of addition, subtraction, multiplication, and division. And they're to be performed first all multiplications and divisions in their order from left to right, then all your additions and subtractions. So pretty simple stuff. All right, so we're kind of done with that. So again, I want to say this is actually a really good website. Not a website, but a Facebook page. The Mathematica.com. This Dr. Rafael Bastos. It's pretty good. He puts a lot of these problems on there. They're pretty funny. He's got a humorous tone to them, but there's some good basic problems for people to practice. And this is fairly simple stuff. I mean, this is an expression, first of all. All right, we don't have an equal sign in there. So it's not considered an equation, but still it simplifies, right? It's an expression that simplifies to 10. Um, but yeah, we kind of went back and forth, and it's kind of pointless, unfortunately. But what I want to say here is that let me put this on slideshow. All right, what I want to say here, I don't want to put this in slide slideshow mode here, but we have the problem 3 times 2 plus 1 times 4. Now, ignore the fact I put an equal sign to a question mark. That kind of makes an equation there with the equal sign, but it doesn't matter. The original post shows it as an expression, which still simplifies to 10. Now, there's this thing that people like to bring up all the time. Sometimes it's a lot of older adults that mention things like mental math or spoken math. All right, and they confuse it with what's written math. It's something they're not able to translate spoken math or what they term as mental math into a written form. Um, because what he kept bringing up in the discussion was that he says, well, if the teacher says take 3 times 2 and add 1 to it and then multiply all of that by 4, you're going to get 28. And he's not wrong. The problem is to write that out, to take that spoken um, expression that I just spoke, means that you have to take 3 times 2 plus 1 and put them in parentheses. Because note what I said. I said take 3 times 2 and add, which gives you 6, add 1 to that, which gives you 7, Then multiply all of that by 4. Multiply that by 4. You will get 28. But if you want to take that spoken mathematics or so-called mental math that is referred to, you have to put the 3 times 2 plus 1 in parentheses. That's the correct written method. When you see it written out like this, 3 times 2 plus 1 times 4, you're not prioritizing 3 times 2 plus 1. You're not putting it in parentheses. This top portion up here is very clear. All right? When you're looking at it written this way, multiplication has always had precedence over addition. And so it's 3 times 2, which gives you 6, 1 times 4, which gives you 4, and equals 10. And you want to look at it as some kind of a spoken problem, you could say, hey, I buy 3 coffees that cost $2 each, and I buy 1 sandwich that costs $4. How much money did I spend? I spent $10. All right. Poor Peter would spend $28 based on how he thinks it should be done. But again, his issue is that he doesn't know how to translate a spoken mathematics problem into a written mathematics problem or the other way around. It has nothing to do with the order of operations. It has nothing to do with the fact that multiplication does come before addition. It's always been that way. And when you have parentheses, again, parentheses give priority to everything that's inside of it. These parentheses tell us to solve the 3 times 2 plus 1 first, and that's where he's failing. But unfortunately, and I can't let this get to me, but fortunately, someone like Peter likes to go on Facebook and start saying things like, "Well, you don't know anything about math. You're basically an idiot." He can do that. He's doing it publicly. That's on him, unfortunately. But yeah, again, and they like to do this kind of thing too. Peter's unfortunately one of these guys, but it says before you people were born in primary school, so I'm assuming he's from the UK. It doesn't matter. People do this everywhere in the world, unfortunately. But before you people were born in primary school, if this question was asked verbally, everyone in the class would get it right. The teacher would say, "What's 3 times 2? Now add 1 and multiply by 4." The class would answer 28. Miss 28. Okay, I'm not sure if you're referring to the teacher. Now try to convince me your system, get that, like your system, not the system that's been in Western civilization since what, the 1500s, the 16th century? Before that, um, elsewhere, I mean, the earliest written books on algebra. Oh, again, I brought up that word algebra. Oh my. So what a load of rubbish. Crash course, I don't think so. You know nothing about maths. And again, I've already said it. What he's talking about doing here is exactly what I explained here. He's talking about taking 3 times 2, adding 1, all of that grouped together and multiplying it by 4. This is the way that it's written. Again, you can go back to the original Facebook post from the really great Facebook page. I highly recommend that. Some really good simple order of operations problems, even some algebra problems are put up there. It's not written this way. It's not written this way. It is written this way. This is a different problem than what he keeps harping on about. But yeah, I hope Peter understands it, but I have a feeling that he's very set in his ways, and no one's going to tell him any different. But I just don't want other people to confuse someone like Peter um, as someone who has a lot of intelligence and competence. Unfortunately, people will come out and they'll have a lot of confidence, but they don't have a lot of competence. And people will misinterpret confidence for competence. And my biggest warning for the day is please don't do that. If you don't think you agree with what I say, go look it up. There's tons of online references. Don't rely on some random blogger. Don't rely just on me. Look it up in a textbook. do some research, find teachers who actually post stuff. This Facebook page is really good. I'm sure he has, I don't recall if he's got his own YouTube channel where he goes through and explains the solutions. He probably does. Go look these things up. Yeah. So anyhow, I'm just going to leave you with that. This is the whole argument that people make over so-called mental math. There's nothing wrong with that. There's nothing wrong with spoken math, reciting it out loud. But if you're going to transfer it over to a written version, you need to know how to do it. And I'll just say Peter doesn't understand that, but he's very confident in his non-understanding. All right, well, I'm just going to leave you guys with that for the day and look forward to seeing everyone in a better video. All right, take care.